Hello, hello. This is Postgres FM episode. I don't remember the number. And today I'm Nikolay, and this is Michael. Hi, Michael.
Hello, Nikolay. I think 85.
Well, it's honestly, it's already at this point, it doesn't matter already.
When we get to 100, it will matter.
Yeah, wake me up. Yeah, at 100. So today I'm in the passenger seat, and Michael is going to talk about. Well, I will join, of course, but from passenger seat. About why the planner behaves not as expected, not choosing index I have prepared, and how to troubleshoot that, right?
Yeah. This was my suggestion. So it's something I see a bunch, and I got reminded again yesterday. I happened to be on LinkedIn of all social networks. It's surprisingly one of the slightly nicer social networks to be on these days, which I would have been shocked by a few years ago. But I saw a post from Brent Ozar, who I remember from my Microsoft SQL Server days, and has been recently getting into Postgres things, which is cool. I think it'd be a great addition to the community. And he'd posted what I thought was going to be a blog post, and he cheekily said, why isn't Postgres using my functional index? And it turned out it was actually a Stack Exchange question that he had posted, and he had included links to an Aurora database, which not Postgres, but Postgres compatible, which is fun. And he was genuinely asking, why isn't it using my index? And I noticed it was only posted sometimes on LinkedIn, you see posts from 3 weeks ago, but it was only posted about 20, 25 minutes ago or something. I thought, there's no answers to this. This is something I generally know about. I've written a whole blog post on. So maybe I can help here. I had a look. And it just reminded me that this is a remarkably common issue for beginners for a bunch of reasons, but even for some quite expert database users, sometimes get confused as to why they've got an index that Postgres should be using, or they think they do. And for some reason, Postgres is either can't use it and they're expecting it to be able to, or doesn't think it'll be faster and is choosing a different plan. So yeah, I've seen this a bunch of times. I feel like there's probably about 10 different reasons it could be, which is, I think, slightly people don't realize quite how many reasons there could be for this. So I thought it might make an interesting discussion.
Yeah, I remember this struggle. Now I know how to troubleshoot it, but I remember this struggle I had many times in the past. It's not easy sometimes to understand why a planner behaves in one way, not as you expected. And sometimes it upsets you a lot and you start thinking, oh, it's stupid. I saw also people started blaming Postgres a lot after such events. They think planner is I want control. Also, this is where you probably want to start wanting this hinting which Postgres lacks, right? It has it, but it's not standard.
Yeah, I think we probably will get to that. You said you now know how to solve it. Out of interest, what's the first thing you'll do?
Well, first thing I'll try to understand, okay, this is the moment. Usually I don't pay attention a lot, but this is the exact moment when I start paying attention to cost metrics in the explain, analyze, buffers plan. So the idea is I try to understand, is it really huge number or it's relatively small or very tiny? And then I think, okay, based on my experience, and here actually it helps if you have some experience, right? Based on my experience, if my index was used, what would be this cost, right? And then, basically, I already explained my algorithm. So, okay, I see some cost. I wanted to say actual cost, but the word actual we must reserve for execution, not for planning, right? But this is the cost you see in the root of this tree of query execution. Actually, we don't need analyze here, right? We just can say explain, and it's enough.
For the total cost that you're talking about,
right.
I guess you're talking about, they're called startup cost and total cost. I guess you're talking about the total cost on the root node.
In the root, yeah. We just we have the plan. We see our index we hoped would be used. It's not present there, and we see different index or maybe sequential scan, and we think, oh, what's happening here? And so I see the total cost. Probably I also check the success method node where data access is happening and the cost there as well. It's also important. And then I think, if my index was used, what would be the cost? And since I'm experienced, I'm sometimes already understanding what's happening. But if I have doubts, I just start playing with these rough knobs, enable sexscan, enable index scan, enable blah blah, to put penalty on specific access methods, right? Or so to specific steps and
scan types.
Yeah, right. Scan types, and in this case, very often I start seeing what I expected, and I see like this would be the cost, and I see the difference, and sometimes it's very small. So we were very close to choose my plan, but it was not chosen just because. And then super often, very often, it's new system, and I ask people, what random page cost do you have?
Mm-hmm.
Right? Because sequential scan, our index is not used. And random page cost is 4. Recently, some Amazon guys, they got consultation with me, and this is exactly what happened. I asked, what random page cost? They said 4. Remember, Crunchy Bridge, after listening to us, changed it to 1.1, and they also published good benchmarks, and it's still in my to-do to revisit those benchmarks, because I had tendency to set random page cost to 1, but they said 1.1 is better, actually, according to our benchmarks, and they had some methodology interesting, but it's slightly off topic. So for those listeners who don't know what random page cost is how the planner thinks about random access to data, right? And by default, it expects you using magnetic disks, rotational disks. And this is not normal in 2024, definitely. And I don't know if Aurora and RDS still have 4. That cluster may be created long ago. But if they still do have this is another question to them. We had the question about CPU and green color in Performance Insights last time, but today we have a new question. We need to check. I haven't created clusters for long. Yeah.
Last time I checked, most of them were. There were a couple of good exceptions like Scale Grid and now Crunchy Bridge, but there aren't many that have tuned it last time I checked, which was admittedly quite a while ago.
This is super strange. And also Postgres community, it's time to revisit this. And we need this mostly for new clusters. You shouldn't think too much about all clusters. They already have PostgreSQL.conf in place and everything there. So change it.
And I would say, why are we optimizing for the few people that are still running on magnetic disks instead of the vast majority who are running on SSDs? Like it's time to change, I think, for the default.
Yeah. I might be again taking too much time for a passenger, but let me just I just feel this that maybe some people don't understand what we are talking about. I will be very short. So there is sec page cost and random page cost. Sec page cost means the cost of sequential data access, and it's 1. If you change it, you change scale. I have cases when people change it, but it's all like it's 1. It's our line, how to say, baseline, right? It's 1. And random page cost by default in Postgres is 4. It expects that random data access is 4 times more expensive than sequential page access, which is not so if you, for example, have all data fit in memory cached, or if it doesn't fit, but you have non-rotational disks, SSD, NVMe SSD, or something like modern disks. And most of new databases have modern disks, of course. And Aurora, I think they have very good storage, so obviously it's not rotational. I think maybe I'm wrong, actually, right? It should not be rotational. It's very slow. I mean, throughput is terrible, right? Okay, so and why does it matter here? Because if you have 1 and 4 default settings, 1 sequential and 4 random access, it's 4 times more expensive. The planner quite often thinks, sequential scan is not that bad. I would prefer sequential scan over index access if I need to fetch a lot of rows, right? Because it seems to be cheaper for me. And once you shift it to normal 1.1 1 is normal these days. Like this is common understanding. And Crunchybridge have good benchmarks. Let's attach the link. So in this case, you tell the planner actually sequential access, random access, they are almost the same. And index scan starts winning. Yeah.
Yeah, or at least it's only a 10% penalty instead of a 300% penalty, which is a huge difference once you start returning a bunch of rows. For a single, yeah, which happens quite often. There's quite a lot. Like, anyway, I'm very happy for you to do a bunch of talking here. It's a pretty common topic. I like that we've gone this deep so quickly, but I do want to go. I think it's worth going back and saying this is a great avenue for like you mentioned looking at the costs, but I think there's an easier, like even for non-experts, you can use that to your advantage, right? You can, if you have access. I didn't when I was looking into Brent's problem. It was a read-only user, so I couldn't do enable scan off, which is the easiest way of if you're getting a sequential scan, flipping it to basically telling the planner that sequential access is tons more expensive than it really is, and therefore if it has any ability to use the index, no matter how expensive it should be, it will then use it. If it can't though, enable sec scan off doesn't actually prevent the planner using sec scans. It just penalizes it. It makes it look more expensive. So if you cannot use the index, which is a bunch of these cases are Postgres can't use the index for some reason, or you've forgotten that you're in an environment that doesn't have the index. Like that is a surprisingly common.
Or an invalid index.
Yeah, well, yeah. I haven't seen that one as off. I haven't seen it come up as often, but quite often people are like in the middle of debugging something and someone's dropped that index, or they're on staging and it doesn't have it when on production they do have it. So it is worth double checking the index exists. But by using enable sec scan off, you can quickly check, is it a costing issue? Now it's trickier with if you the case you mentioned where it's doing it's using one index and not the one you're expecting. You can't use that. If it's you can disable different scan types, but you can't tell it not to use a specific index. I have seen a trick for that though, which I wasn't familiar with before, but Haki Benita shared on a blog post. He does a begin transaction, drop index, the one that it was using, explain the query, and then roll back, which means you can try and see if that index didn't exist, would it pick my index, which is quite a nice trick as well. So trying to find out, are you in the case where Postgres can't use the index, or are you in the case where it's choosing not to? The enable parameter is a really nice way of like finding that out quite quickly normally. So yeah, cool that you start there as well, even if you're eyeballing the costs. The one thing I would add on that is I think explain analyze can be helpful. So if you've run that already, or if your query actually runs and doesn't time out, then the explain analyze part is helpful because you get the rows returned. And I think when the cost estimates are off, sometimes it's random page cost, but quite often it's about the number of rows Postgres expected to be returned and the number of rows that are actually returned. So in fact, maybe actually you don't need to analyze, because like if you know the query, you know the data, you know the query you're running, if you're expecting only a few rows to be returned and you see hundreds of thousands in the estimate, you've got a pretty good clue right there that you're in a case where it's overestimating the cost of that.
Or underestimating maybe, but yeah, underestimating wouldn't lead to index not being used, but anyway, it can lead to wrong plans. And yeah, that's a good point. So this is the reason number one, let's say. First reason is like costs are slightly different, but this is like already I'm talking about the most difficult case probably. There are easier cases. I just excluded them from my mind because they are easy, right? If cost is off, and indeed we check the planned rows and actual rows, if the mismatch is huge, either it's outdated stats, probably somebody is blocking auto vacuum or something we need to check, or maybe lack of stats. Not like sometimes we don't have stats at all. Like it happens. For example, if you created a functional index but you didn't run analyze at all yet.
That was the case yesterday.
Yeah. In this case, explain analyze buffers also is good. I agree with you. But yeah, but sometimes you have the query which lasts hours. So in this case we need to downgrade to just regular explain and see only the planner.
Mm-hmm. Well, this is one of those, like, I'm obviously a big fan of explain, analyze buffers like you, but this is one of those cases where I don't think you can know, like maybe you can never know, but I don't think you can know from a single execution plan which case you're in. We often need at least two. We need like the before and the after we've changed one of these parameters. The first one's not going to tell us that much. It tells us it's not using the index, but it doesn't tell us why it's not using the index. We could get some clues like row estimates being off or like the cost number, but they're only clues. Like it's only by changing something and running it again that we can see the difference of when it is using the index.
That's why database branching and experimentation with iterations matters so much, because if you already calculated statistics, but then you start having questions, what if I did something like different? You want to reset and go different route, different path, right? In this case, being able to iterate, like reset in a few seconds, run it again, check this idea, check that idea. That's why branching and fast thin clones matters so much, right? Exactly. This is because otherwise it's a one-way ticket. So you already calculated statistics and that's it.
Yeah, true. Actually, you can't go back. You can solve your problem, but you can't go back.
Right. And sometimes you solve the problem, but you cannot explain in detail what happened. But this doesn't build confidence in your team if you cannot explain, right? And to explain, you need to go back.
Yeah.
And understand better. Yeah.
I like that you're using explain in a different context now.
Okay, but it's related, right? It's related.
It is. It really is. And then you can analyze what you're going to do next.
Right. Analyze word is overused.
Yeah. Well, that's exactly what happened yesterday as well. There's an interesting thing here that I jumped to conclusions a little bit. I did spot it was probably an estimation error, but I thought it might also be a data type casting issue, which is the kind of thing that we didn't cover that in depth actually. We covered
mismatched query, right? Let's call it mismatched query, maybe.
Yeah, so that basically, if your query can't be answered by the index you have, so if like the typical example of this is a function. So, for example, if you're running
expression
lower on expression on a field, but you have only the field index, and you might think logically that it could use the index. Like if, for example, you're in your
date. From timestamp to date, your reduction from timestamp to date, for example, it's very common. You convert timestamp to date and expect that an index on timestamp will work. It won't, right? Because it's for timestamp, not for this, not for your expression.
So in some cases, Postgres handles some of these data type conversions, like text to varchar, which I wasn't sure about yesterday, but in some cases it doesn't. So it depends whether it supports that. But in general, that's the kind of thing that can prevent the use of an index that you're expecting to be used, or like the operator not being supported. Like there's other cases where the index type so let's say you've used a B tree, because that's what most of us are using most of the time. One example is on a text field using I-like. So like again, a case insensitive search operator is not going to use the B tree index. Indexes only support certain operators, and if you're using an operator that it doesn't support, like a greater than on a hash index, for example, or anything other than the equality on a hash index, it won't use the index, kind of obviously. So I think there's a few cases that are quite simple for why it can't use the index, and then there's a bunch that are a bit more complicated along the lines you were talking about, which is what I've just classified as Postgres doesn't think it will be faster. So yeah, we've said expensive and cheap a few times, but those costs, while they're in an arbitrary unit, the idea is for them to estimate how fast the query will be, or like how slow it will be. The higher the cost, the slower it would be. That's the idea. And it's not the only measure that Postgres could have tried to optimize for. Like it could have tried to optimize for I/O, and that's correlated, but it's not the same thing. Like it optimizes for speed, which is interesting and kind of leads us to what could have gone wrong. So I actually think we didn't cover a whole case though, like a whole simple case of it doesn't think it would be faster and it's correct. That's a case that catches people out a bunch. Like you're trying to force it to use an index, But it's doing the faster route already.
For example, if you read 95% of your table, just sequential scan might be much faster and on the fly filtering out those 5% that are not needed than walking on the tree, B tree, right? It will be probably, even if you balance random page cost and index sec page cost, it still might be better to use sequential scan in reality. So
yeah, for sure. And because of how sequential scans work, because of how efficient they are and the fact they don't need to read data from multiple places, and if your data fits really tightly on like very few pages, it could be a lot faster, and not even just at percentages as high as 95%, based on like for small tables, with like not very wide rows, I've seen it be as low as 30% or so. That's still faster as a sequential scan. So I suspect you come up with a contrived example of it being even lower.
Right. So in this case, I have very simple, very basic question, and I think we should, in many cases we just should start from this question when we consider performance of a query. We should think how much data, underlying data, do we have, right? And next, very high level, how many rows return? Then it can be like, if we can unfold this and say, okay, if it's just one row, was it aggregate? So we needed to analyze a lot of rows for real, or just we return. I last week I had a case. People complained about very slow, like very bad behavior, and they used explain-analyze buffers. They saw like some gigabytes of data and so on. And they knew, ORM or GraphQL was involved, I don't remember, but they knew that they need only like not a lot of rows. And then we just saw that like, oh, it's bad. And the question, how many rows were actually returned? And they also we created all indexes. The indexes are here, but somehow it's still sequential scans and so. But how many rows? And we saw like, oh, actually it was like 10,000 rows or so, maybe 100,000 or 2,500 rows. I don't know, a lot of rows return. Do you really need it, or you just forgot the limit? So limit is applied on client side maybe, right? It's terrible. And then I said immediately, like, I'm a big fan of using, again, like, or maybe off topic, but I'm a big fan of using in larger projects, not in tiny projects when you like care about everything in your pet, right? So queries for me, like, this concept, pets versus cattle, right? So for virtual machines or for real machines, for big fleet of infrastructure. Here, in the case of workload, if a workload is complex, I'm a big fan of dealing with queries like with cattle as well. So when I saw this, it was a new client. When I saw this, that they had this problem, returning too many rows unexpectedly, I immediately said, stop here. Like, it's just one example of the problem. And let's return to high level top down analysis using PG statements, because it has a rows metric. And let's see the whole picture, how many other queries behave similarly and return too many rows. But this is exactly when it happens, index is not used, because you request for too many rows here, right? And selectivity is not good. It's very weak.
Yeah, and Postgres is going to do exactly what you asked it to do. If you want all of the rows, it's not going to say, oh, let me give you the first 25 and see if that's enough. It's going to say, nope, here you go, here's all of them.
Unless it's PG vector, which is slightly uncertain, right? And it's something new for
good
us.
Point. Yeah, I haven't actually considered the new index types.
Yeah.
Anyway,
no more certainty in the SQL world.
Yeah. So. But yeah, there's another case as well. A big one is if you're selecting a high proportion of the table, chances are it's actually faster to do a sequential scan. Possibly a different index is serving, like a different index might be serving your query better. I haven't seen that one as often. But another case that I've seen really often is small tables. So even if you're only selecting one row in a table that's like fewer than 100, which might not be that common in production. I've seen quite a few like reference tables though that are not very many rows. Or more commonly, developer databases on people's local machines where they just have a tiny bit of data for like a new feature. Even if you have the perfect index, Postgres won't choose to use it when you don't have much data, just because it's all the data's on one page and it can just simply look it up very, very quickly, very, very easily. So small tables are the other exception that I see more often because of dev boxes.
You know exactly how easy I can be impatient here, trying to interrupt you, right? This is my favorite topic, and like probably I will not add anything here. And listeners who follow us for long already know what would I say here, right? Because you should always try to deal with full-size databases.
Yeah, or at least like a
bigger
large data sets. Yeah,
right,
if you're going to have to, yeah. But it trips people up.
Unless you're a big fan of hypothetical approach, HyperPG and indexes partitioning, so it also would work, but in a limited way.
Would it though? Because if you don't have any data, I don't think.
No, sorry, it was not. It was only discussed, not implemented. And there was another project which like let's export statistics from production, import it to our environment, and pretend we have a lot of data.
That's a cool idea.
Yes, it's a cool idea. Maybe already. HyperPG has been developed, so definitely partitioning was covered. But about statistics, maybe no. But there was another project developed in Japan, I guess, and it's not super popular, but idea is cool. I think it's really good. But I expect some limitations of this idea. Obviously, if you can afford testing on full-size databases, this is the best way.
Yeah,
you just need to make it cheap, and then here I stop.
Yeah, nice.
Okay.
But yeah, this is the more interesting case though, right? Like once you're past those two of it being, actually faster, if it's wrong, if Postgres is not estimating correctly, that's when we get into the more interesting parts of like, you mentioned stale statistics or not even having statistics that are relevant or needed. So analyze is your friend here on the tables in question. We've also got a couple of other tools. We can increase the statistics, like we can increase the sample that Postgres will do if you've got like an oddly distributed
default statistics target. Yeah, some people
not even
for one column.
Yeah, exactly. You can do it globally, but per column.
But 100 default 100 is also quite a lot. It might be not enough if you have high insert rate and constantly working on the edge of like new data, and the distribution of values in new data is very different compared to the archive data. So there are things there definitely.
That's one of the defaults I'm happiest with, actually. I think it's a pretty good sweet spot, because increasing it, if you increase it globally, you increase the time for analyze to run globally, and I think that has knock-on effects for things like your downtime for doing certain types of major upgrades and things. So I can see
zero downtime, and if you jumped from 100 to 1000, yes, it will probably increase analyze time maybe 2 or 3 times, but not 10 times. It's not linear.
Sure, but I haven't seen it cause huge problems globally. But yeah, if you've got a column that's like not in a skewed distribution, increasing it for that column can really help. And then the final one I've got on my list was the multi-column. Yeah,
which can be only for columns inside one table.
Yeah,
it cannot be, unfortunately, for 2 tables, two different columns in 2 tables. It would be interesting to have maybe as well. Sometimes one table fully depends on another, right? And yeah, I don't know. What?
We do have a whole episode on hints, but I think this is where the hints discussion really comes into play. It's like, what are your options when we're out of tools within Postgres to give the planner as much information as we can about the distribution and the stats?
Bugs also happen. So bugs might happen. I mean, planar bugs or some not yet developed things, some easy stuff which is not yet there. Postgres planner is not super powerful. It's quite powerful, but compared to SQL Server, for example, the code base is much smaller, and the amount of the number of engineering hours invested to SQL Server Planner are much bigger than into Postgres. So of course it's evolving, but still some things might be not yet developed, and sometimes people see quite simple things. To me, like sometimes you think, oh, it's so like obvious. Why it's not here? And as an example, it's very unrelated, but it's still Postgres. Last week, transaction timeout was committed by Alexander Korotkov. Many thanks to him. And transaction timeout was my idea. And it was when I came to this idea, I was thinking, am I stupid? Like, am I missing something? Like, whole world still didn't raise this. I searched. I don't see discussion. Why transaction timeout is not present in Postgres still? Like so many dozens of years of development. And then a few folks validated it's a good idea actually, and then it got support. So if you spend time with Postgres enough with Planner, you might indeed see cases which are not yet well developed, or just simply bugs. Sometimes just bugs happen as well.
Yeah, I've spoken to several customers that have long histories with DB2, Oracle, and they're surprised by some things, but they also talk about some issues with, like, especially on the Oracle side, about kind of patchwork solutions. So sometimes more code in these optimizers is not necessarily better because it's like patched fix on patched fix on patched fix, and it leads to quite nasty weird behaviors. So I do admire the elegance of the simplicity, but equally I think you're right. People I know that know these things well, or have used SQL Server or SQL Server or DB2 in the past, definitely say nice things about those planners.
Well, my opinion is also based not on my experience. My last experience outside Postgres was like very long ago. I mean, real experience when you do develop something for long. It was more than 15 years ago. So I'm just translating other folks' opinions, but they seem reasonable, these opinions, and they are experienced guys who actually came to Postgres and say, like, let's just admit the planner can be much, much better. We need to continue developing things, improving things. And in this case, let's advertise a recent blog post from David Rowley. Right.
Yeah.
So I've noticed many items, it was his contribution, right? So
but also many from other people too.
Yeah. So like the post is what's new in the planner in Postgres 16. Let's like unfold it and so on, and it's great. It's also in my to-do to inspect deeper and maybe do some tests. So it's a good post, very good post.
And the thing I love most about it was inspiring people to upgrade. Postgres 16 came out a few months ago now. We had some minor, at least
16
one,
too.
I think 2 now minor patches. Yeah.
February release.
I already know at least a company that has upgraded as a direct result of that blog post coming out, just to see if some of their queries improved as a result.
Cool.
Yeah.
Cool. Good.
So yeah, thank you to David.
This is important to share, by the way, because other people think like maybe it's still too early and so on. And like I recently was approached and just with the question, do you know anything bad about Postgres 16? And I said, no, actually, it's not Postgres 9.3. No. 9.3 was terrible. I remember it.
I think I've got a new answer for you that I think is more on brand. I think you should say yes, but they're also true in 15, 14, 13, 12, 11, and 10.
Okay. Yeah.
Anyway, I know what you mean. Did you mean like you don't know anything bad in 16 that's new in 16?
Nobody bumped into some problems like complaining that it's bad. Already a few companies upgraded. I mean, maybe not huge installations, but still, like, and it has good reputation so far. And of course the risks are still there, and tomorrow we might see some problem. But these risks already go down and down over time, right? And I mean, it's important to share. So, like, we upgraded, everything is good in our case. It doesn't mean in any case
true.
It will be good, but it builds up a level of confidence over time, and more people will be upgrading. So,
nice one.
Okay, good.
Did you have anything else you wanted to add?
No. I always have a lot of things, but I think we're out of time. Let's not consume a lot of time. We should, like, of course, it's good if you run more or walk your dog more, listening to us longer, but still there are other things to do. So thank you so much, and thank you for support. We still I didn't follow really well, but we see comments on YouTube, for example. It's good. Please share your experience as well, and other people also see it, and we can highlight some comments, not only about Red Bull, right? And or beer. It's so
Free advert. I'm teasing.
yeah.
Yeah, about that. Like, I think over 1,000 people have listened to the last few episodes, which is pretty cool.
Yeah.
So thank you all.
Good. Okay.
Cheers,
See you
Nikolay.
later.
Take care.
Bye bye.
Bye.